and we will go to the next presentation that will be given by Dr. Oded Katz. He will talk on the submarine landscape of the Mediterranean Israeli Continental Slope. Dr. Katz is a geologist studying rock mechanics and landslide mechanics and hazards. He got his PhD at the Hebrew University of Jerusalem, and since 2003 he is a researcher at the Geological Survey of Israel. Oded, please.
Thanks. The work that will be presented here is the master thesis of Einav Reuven, which is supervised by Einat Aharonov and myself. This work is a study of the bathymetry and the near-surface geology of the coast of Israel. Study area is shown in this map, and we are not the first to do it, but the new thing in this work is that we had the new bathymetry grid. That is the work of Ronnie Sadeh with the endless contribution of John Hall, of course. The resolution is 15 meters till the depth of about 700 meters. This is about the blue line. This is the scale. And deeper than that, the resolution is coarser, is 50 meters. The motivation is of course, to study the slope, the continental slope, which all the landslide, the submarine landslides, this is the result of the mapping. The submarine landslides are the black, colored in black, and the lineaments that we will talk in detail later. These are the yellow, over there, and of course, this is interesting in the sense of its natural system, and it is also interesting in terms of hazard evaluation, landslides and active faulting, what's going on in this slope when there is an earthquake in the Dead Sea Rift. And looking at that, of course, any pipeline that from the gas finding over there in water depths of 1,500 meters will have to climb up the slope to the shore, and will have to cross this landslide and lineament field. So we better know what is going on there. So the objective of the work are here, and in this talk we will see the mapping of the landslide and related surface features, basically what we see here on the map, and we acknowledge here some of the previous work that gave us the directions before we could map it ourselves. Funding. We got some startup money from the Steering Committee for Earthquake Preparedness of Israel, and then we got a generous fund from the Ministry of Science and Technology to work together, 6 universities and research institutes with researchers covering geology, geophysics, and engineering approaches. Okay, so what is the continental slope? I guess you all know by now after these 2 days. The continental slope, or the coast of Israel, started the continental shelf up to, all in all, a flat area up to water depths of 100 or 200 meters. Then the slope itself goes to water depths of about 1,000 meters, and then again the more or less flat area of the deep water. This is 10 times vertical exaggeration, and this is with no vertical exaggeration, where the slope is, all in all, an average of up to 4 degrees. In general, we can divide the study area into two provinces. In the north, just seawards of Haifa, the slope consists of canyons, which incide into the slope. This is one province, and in the south of Haifa, we have an open slope with landslides. And of course, we will try to answer the question, why are these two provinces and what makes the difference between these two appearance of the slope, but this is not in this talk. The two large or known or main features in the continental slopes are the Dor and Palmachim disturbances. These are large landslide-like feature. This is the Dor disturbances, and this is the Palmachim disturbances. But we are not studying them, and I will not talk about them. I will talk on these smaller and shallower landslides that appear near the Palmachim landslide, and this kind of shallow landslide caught less attention in recent years. In terms of the geological structure, again, I guess everybody knows that by now. The relevant geology is the Methenian evaporites at the depth of 1.5 kilometers approximately below the sea bottom, and the Pliocene Quaternary silt and clay, which are above the Methenian evaporites. This drawing from the Almagor and Garfunkel paper some more than 30 years ago. They already noticed the growth fault from the Methenian evaporite over to the surface, and these features that are the surface ruptures of these growth faults from that cut the surface. In terms of the formation, the slope itself is under an extension because of the creeping post-Methenian sequence over the evaporites. Okay, when studying landslides, one way to connect the deeper structure and the surface feature is use the similarity that exists in the geometry of landslides. The thickness of a landslide from the sliding surface to the surface is dependent or is related to the length of the landslide. This is in 2 dimensions, and in 3 dimensions, the area of the landslide and its volume are also dependent. And this is T over L. It's about 0.1. So if the Palmachim landslide or disturbance is about 10 kilometers, the length of it is about 10 kilometers, so we will expect that the sliding surface will be at the order of 1 kilometer deep. This means that is probably on top of the Methenian evaporites, and the shallow landslides that we will see in a moment are about a kilometer long, and so they are shallower, less than about 100 meters or so, and these are within the post-Methenian clays and silts. We mapped the landslides in the southern province because the scale of the landslides within the canyons is much smaller, and it's a different mechanism. So we will talk now only on the southern province. All the landslides that we could find, about 100, are marked here by this light purple color. And the gray map is a slope map. The white or light gray is a slope of close to 0, where the black is 15 degrees and more. The canyon slopes are more than 15 degrees, so they appear in black. And the open slope is less than 15 degrees, so gray colors. What can we see in this map? First, we can see that there is a decrease in landslide size south to north. These are quite big landslides, and here they are small. The headscarp of the landslides are following a line here in the south and also here. And the shape of the landslides involve more flow in the south, these flow structures, and in the north they are much more slump-like landslides. Looking at the Palmachim structure and also the door structure, we see no landslide inside the Palmachim structure. Simple geological arguments will tell us that maybe this is the youngest structure in the system, because there are no later landslides that develop inside the Palmachim slide. But on the other hand, it might be that the slopes inside the Palmachim landslides are shallower than outside, and that is the reason that there are no landslides inside the Palmachim structure. And the door structure, door disturbance, just push the landslide away over to the coast. So it might be also point that this is a younger structure. But this is just questions that we are not sure yet. Now zoom in on the shallow landslides at this area. We identified few types of landslides. This is a simple one. It is on the right side there is a map, and on the left side there is a perspective view. Again, the colors, the gray colors are the slope, close to 0, few degrees, and black is 15 and more. There is the lineament, and within the lineament there is the landslide scar and the deposit. Over here, again, the scar and the material that moves down slope. It might start as a slump, but later the material continue to flow down the slope. The dimension are the height of the scar is the height of the step here. It's about 15 meters, and the width of the scar is less than a kilometer, and we call it simple because it's only one headscarp. The second type are complex and apparently older landslides. There is the outline of the landslide and the scars are much complex. This is one of the landslide that is identified here. This is a second, maybe a third, a fourth, and there are the primary landslide, and then secondary, and then another tertiary or secondary landslide. So there is a process of retreat of the landslide up the slope. And now looking at the simple landslide was just triggered from the slope, so apparently older, triggered from the step, so apparently older than it. And here this is the step is the lineaments that we will talk later about them, but we can see that this step just cut this landslide. So in this here the step is older than the landslide, and these are the complex landslide. Landslide from the south side. This one is about 5 meters wide, and it's less complex in its appearance, but there is also a secondary structure, a small landslide that is triggered from the scarp of the large one. So these are the types of landslide that we could identify. Then we will now let's zoom in on these lineaments that are steps in the slope. They can be like 10 kilometers long, north-south in the direction, and kilometer or 2 kilometers separation between the lineaments. In a map view, this is west-east, or this is north. These are these steps, or in the perspective view, this is one of them, this is the second. These are a few tens of meters high, and they in this picture they cut this landslide. This is the landslide in the upper side of the step, or this lineament. This is the landslide in the lower side of the lineament. Trying to connect them to the deeper structure. This is a seismic line. This is its trace over here or over here. Well, it was written here that this fault interpretation is made by Ecolog, but not seeing. And this is the part that is showing here is part of the map that is within this frame, and this is a very freehand correlation between faults that were identified in the seismic line and the lineaments that are shown on the surface on the sea bottom. So there is a quite good correlation. So again, as was identified by Almagor and Garfunkel some 30 years ago, we can agree that these lineaments that we mapped are the surface expression of the growth fault, and they are cut and displace the shallow landslides. And in some places, the shallow landslides are triggered from the scarp of these growth faults. The third feature that we could identify are trenches. This is a map view. We are here. This is a map view and a perspective view that is flipped over. So this is the channel. It is about a few hundred meters, or even few hundred meters wide. The walls are a few tens of meters high, and these are occur further down the slope, down, of course, from the landslide line, and also down from the steps. In the seismic profile, we see that there are some steps like features on the surface, which are connected to faults that are going down to the Messinian evaporites. So this is again the expression of the growth fault, and it might be that this is a channel-like situation and not a step-like situation, because the slope here is shallower and there is less displacement of the clays and silts over the Messinians. Okay, so to summarize this, again, the map of the landslide and the lineaments that we could identify. Overall, there is a trend that the landslides, these shallow landslides, are getting smaller and smaller as we go northward. Landslide and these lineaments, the surface expression of the growth fault are contemporaneous. Part of them are part of the landslide triggered from the steps of over the ghost folds. Some of them are cut by these faults, and it is saying that the dynamic of the system is an expression of the creep of this pile of sediments over the Messinian evaporites, although the landslides are shallow and they are not in direct contact with the evaporites, with the Messinian evaporites that are deep, over a kilometer deep into this sequence. So these preliminary results are showing that there is a system here that it's worthwhile to study, and it will be information that I think it will be important to any infrastructure or pipelines that are going to be built over this continental slope. And this large group of researchers that are going to spend much time in the next 2 years trying to understand the system. So I expect a lot more of information to be a result of this work. Thanks.
Okay, thank you. We can have one quick question. Yes, please. Can you speak loud?
Let's add to it something else. Can you give a time perspective to the activity or the highly dynamic nature of this slides?
One of the important questions that we will try to answer in the next year or so is, are these landslides earthquake induced? If we expect that if we have a large earthquake at the Dead Sea, it will cause some landsliding over the continental slope, or this is when we will know what the answer here. So this is information that can be used, and if not earthquakes, what is the triggering mechanism, and at all if this landslide system is stable or not. We don't know that yet.
Okay, thank you. One more quick question, okay?
The same type of features exist. The same type of features exist off of Norway, off of Western Australia, and in the Gulf of Mexico, where we lay pipelines. And they look very similar to what you're showing here. Have you studied them to see if there's a difference?
Well, I looked at the one that in the Gulf of Mexico, and it seems that there the slopes are much shallower, and they are not reaching this over 15 degrees slopes. The submarine slopes is quite. Okay, so we will look at that and we'll try to compare.
Okay, thank you, Oded.